it is generally not permissible to install a water sprinkler system coverage over electrical equipment. Water can damage electrical components, insulation, and wiring, leading to electrical failures, short circuits, and fires. Water can accelerate corrosion of electrical equipment, reducing its lifespan and reliability. Top-vented enclosures allow water to enter through the vents, potentially damaging internal components. Water-resistant motor housings may not be completely waterproof and can still allow water penetration, especially over an extended period of time. Alternative fire protection measures should be considered for electrical equipment, such as fire-rated enclosures. Enclose electrical equipment in underwriters' laboratories or UL-rated fire-rated enclosures to prevent fire spread. Install fire suppression systems specifically designed for electrical equipment, such as dry chemical or gas extinguishing systems. Install smoke detectors and warning systems to alert personnel of a fire in the area. Perform regular maintenance and inspections to identify any potential fire hazards and ensure proper operation of electrical equipment. It is important to collaborate with a qualified electrical engineer, fire protection engineer, and the local fire department to determine the appropriate fire protection measures for the specific facility and equipment in question. A risk assessment should be conducted to evaluate the potential hazards and determine the most effective mitigation strategies. Local fire codes and regulations may vary, and it is crucial to consult with the local fire department for specific requirements. Fire poses a significant threat to electrical installations, and selecting appropriate fire protection measures is critical for ensuring safety and minimizing damage. Wet pipe sprinkler systems, while effective for general fire suppression, present inherent risks when applied to electrical equipment. These risks primarily stem from the conductive nature of water, which can lead to short circuits, equipment damage, and potential hazards to personnel. Therefore, alternative fire protection strategies are generally recommended for electrical environments. Firstly, fire-rated enclosures are a robust method for containing fires within electrical equipment. These enclosures are constructed from materials that can withstand high temperatures for a specified duration, preventing the spread of fire to surrounding areas. They are particularly effective for equipment with a high fire risk, such as transformers, switchgear, and motor control centers. Secondly, fire suppression systems designed for electrical equipment offer targeted protection without the risks associated with water. Dry chemical systems use a non-conductive powder to extinguish fires by interrupting the chemical reaction. Gas extinguishing systems, such as those using carbon dioxide or inert gases, displace oxygen and smother the fire. These systems are often used in areas where sensitive electronic equipment is present, as they leave no residue and minimize damage. Thirdly, smoke detection and warning systems provide early detection of fires, allowing for prompt response and evacuation. These systems use sensors to detect smoke particles in the air and trigger alarms to alert personnel. Early detection is crucial for minimizing damage and preventing injuries. Fourthly, regular maintenance and inspection are essential for identifying and addressing potential fire hazards. This includes checking for loose connections, damaged insulation, and overheating components. Regular maintenance can prevent fires from starting in the first place. When selecting fire protection measures for electrical equipment, it is important to consider several factors. The type of equipment, its location, and the potential fire hazards should all be taken into account. A risk assessment should be conducted to evaluate the likelihood and potential consequences of a fire. This assessment should involve qualified electrical and fire protection engineers, as well as the local fire department. Collaboration with these experts is essential for developing a comprehensive fire protection plan that meets the specific needs of the facility. Local fire codes and regulations should also be consulted to ensure compliance. These codes provide guidance on the types of fire protection systems that are required for different types of occupancies and equipment. It is important to stay up to date on the latest codes and regulations to ensure that the fire protection measures in place are effective and compliant. In addition to the specific fire protection measures mentioned above, there are several other general safety practices that can help to prevent fires in electrical environments. These include keeping electrical equipment clean and free of dust and debris, avoiding overloading circuits, and using surge protectors to protect against power surges. Electrical safety training for personnel is also important to ensure that they are aware of the potential fire hazards and how to respond in the event of a fire. While wet pipe sprinkler systems are generally not recommended for electrical equipment, there may be certain situations where they are considered acceptable. This would typically be in areas where there is a high risk of fire from other sources, such as combustible materials, and where the electrical equipment is adequately protected from water damage. In these cases, it is essential to consult with qualified electrical and fire protection engineers to ensure that the sprinkler system is designed and installed in a way that minimizes the risks to electrical equipment. One approach is to use a pre-action sprinkler system, which requires 2 separate events to occur before water is released. This reduces the risk of accidental water discharge. Another approach is to use a dry pipe sprinkler system, which uses compressed air to keep the pipes dry until a fire is detected. This eliminates the risk of water damage from frozen pipes. Ultimately, the decision of whether or not to use a wet pipe sprinkler system over electrical equipment should be based on a thorough risk assessment and in consultation with qualified experts. The potential benefits of the system must be weighed against the potential risks to electrical equipment and personnel. In many cases, alternative fire protection measures will provide a more effective and safer solution. Remember to consult with local authorities and relevant safety standards before making any decisions regarding fire suppression systems in electrical environments. It is crucial to prioritize safety and minimize the risk of damage to equipment and injury to personnel. Continuous monitoring of electrical systems can also help prevent fires. Implementing systems that track temperature, current, and voltage can provide early warnings of potential problems. These systems can automatically shut down equipment or alert personnel to investigate further. Regular thermal imaging of electrical panels can also reveal hot spots that indicate loose connections or other issues. Addressing these issues promptly can prevent them from escalating into fires. Furthermore, consider the layout and design of electrical rooms and equipment areas. Ensure adequate ventilation to prevent overheating. Maintain sufficient clearance around equipment to allow for inspection and maintenance. Use non-combustible materials for walls, floors, and ceilings. Proper design and layout can significantly reduce the risk of fire and improve the effectiveness of fire protection measures. When selecting electrical equipment, choose models that are designed with fire safety in mind. Look for equipment that is certified to meet relevant safety standards and that incorporates features such as thermal overload protection and arc fault circuit interrupters RFCs. These features can help to prevent electrical fires from starting in the first place. In addition to the technical aspects of fire protection, it is also important to consider the human element. Ensure that personnel are properly trained in fire safety procedures and that they are aware of the location of fire extinguishers and other fire protection equipment. Conduct regular fire drills to practice evacuation procedures. A well-trained and prepared workforce can significantly improve the response to a fire and minimize the potential for damage and injury. Finally, remember that fire protection is an ongoing process. Regularly review and update the fire protection plan to ensure that it remains effective and compliant with the latest codes and regulations. Conduct periodic inspections of fire protection equipment to ensure that it is in good working order. Stay informed about new technologies and best practices in fire protection. By taking a proactive and comprehensive approach to fire protection, you can create a safer environment for personnel and protect valuable electrical equipment from damage. The integration of smart technologies into fire protection systems is also gaining traction. Smart fire detectors can differentiate between different types of smoke and can even identify the source of a fire. These detectors can send alerts to smartphones and other devices, allowing for a faster response. Smart sprinkler systems can be programmed to target specific areas of a fire, minimizing water damage. Smart fire suppression systems can automatically shut down equipment and activate ventilation systems to control the spread of fire. These smart technologies can significantly enhance the effectiveness of fire protection systems and improve safety. When designing a fire protection system for electrical equipment, it is important to consider the specific characteristics of the equipment and the environment in which it is located. For example, equipment that is located in a dusty environment may require a different type of fire suppression system than equipment that is located in a clean environment. Equipment that is located in a high-temperature environment may require additional cooling to prevent overheating. The design of the fire protection system should be tailored to the specific needs of the application. In addition to the fire protection measures discussed above, it is also important to have a comprehensive emergency response plan in place. This plan should outline the steps that should be taken in the event of a fire, including evacuation procedures, fire suppression procedures, and communication protocols. The plan should be regularly reviewed and updated to ensure that it remains effective. The emergency response plan should also include provisions for training personnel on fire safety procedures. Personnel should be trained on how to use fire extinguishers, how to evacuate the building, and how to report a fire. Regular fire drills should be conducted to practice the emergency response plan. By having a comprehensive emergency response plan in place and by training personnel on fire safety procedures, you can significantly improve the safety of your facility. Consider the potential for arc flash hazards when selecting fire protection measures for electrical equipment. Arc flash is a dangerous electrical phenomenon that can occur when a short circuit creates a high-energy electrical arc. This arc can generate intense heat and pressure, causing severe burns and other injuries. Fire protection measures should be selected that minimize the risk of arc flash. For example, fire-rated enclosures can help to contain an arc flash event, protecting personnel from injury. Arc flash relays can detect an arc flash event and quickly de-energize the electrical equipment, reducing the severity of the event. Proper grounding of electrical equipment is also essential for preventing arc flash. Furthermore, review the National Electrical Code or NEC Article 110.16, which addresses arc flash hazard warning. Proper labeling of equipment can help to mitigate this risk. The Occupational Safety and Health Administration OSHA also provides guidelines that should be adhered to. When evaluating fire risks, consider not only the electrical equipment itself, but also the surrounding environment. Are there flammable materials nearby that could contribute to a fire? Is the area prone to other hazards such as floods or earthquakes that could damage electrical equipment and increase the risk of fire? A comprehensive risk assessment should take all of these factors into account. It is also essential to document all fire protection measures and procedures. This documentation should include the design of the fire protection system, the results of the risk assessment, the emergency response plan, and the training records for personnel. This documentation can be used to demonstrate compliance with fire safety regulations and to track the effectiveness of fire protection measures. It is essential to consider the long-term costs of fire protection when selecting fire protection measures for electrical equipment. While some fire protection measures may have a higher upfront cost, they may offer significant long-term savings by preventing fires and reducing the risk of damage and injury. A cost-benefit analysis should be conducted to evaluate the long-term costs and benefits of different fire protection measures. Remember that fire protection is not just a matter of complying with the regulations. It is a matter of protecting people and property. By taking a proactive and comprehensive approach to fire protection, you can create a safer environment for everyone. And lastly, think about future expansion and changes to the electrical system when designing fire protection measures. Fire protection system should be designed to accommodate future growth and changes to the electrical system. This may require the installation of additional fire protection equipment or the modification of existing equipment. It is important to plan for the future to ensure that the fire protection system remains effective and compliant.